Point clouds can be used in Civil 3D, and they allow us to display and use large point datasets. There's also support for creating surfaces from these point clouds, and those surfaces can then be used for typical things like volume calculations and as targets for grading or corridors. Point clouds are also supported in the core AutoCAD product. However, they don't have functionality that Civil 3D does, like working with surfaces, and we will not be covering the core AutoCAD functionality in this lesson. Today, scanning is replacing some traditional point-by-point methods of surveying. And by creating these point clouds with scanners, the data is much richer, and we can have tens of thousands of points collected every second. This gives us a much greater detail and resolution to the data set that is created. It can include some details that are even difficult to see with the naked eye. And these details may not have even been part of the original scope of work, but they may be picked up and can be useful within the project later on. LiDAR, or light detection and ranging, is one common method of collecting the data used in point clouds. LiDAR data can be collected a number of ways, and one of them is by using an aerial survey. This typically gives us a relatively low resolution data set, and it uses a laser scanner that is mounted on the aircraft. It collects X, Y, Z, and intensity information in the dataset and can be integrated with digital photography. Datasets collected in this method are typically hundreds of millions of points. LiDAR data can also be collected in a ground-based method. With this method, you have a fixed scanner that is typically mounted on a tripod. This gives us higher resolution data, while it still uses a laser scanner to collect the information. This also has X, Y, Z, and intensity data that is collected for each point, and it can and often is integrated with digital photography. These datasets typically consist of tens to hundreds of millions of points. It just depends on the size of the site. Surveyors will set up registration targets that can be used to stitch together multiple setups on a job site. LiDAR data can also be collected from a mobile or moving vehicle. In this case, the laser scanner is mounted on a car or truck, and it again collects X, Y, Z, and intensity information. This is also often integrated with digital photography. And depending upon the size of the site and how far the vehicle is driven, the dataset can be millions to even billions of points. Other forms of data that can be used in point clouds include ground-penetrating radar, temperature sensors, pressure sensors, and bathymetric surveys. The file formats that the information that will be used in the point clouds is stored in can include LAS. It includes XYZ, intensity, and classification information. The intensity includes information about materials and its reflectiveness. And the classification would include things like ground, vegetation, buildings, and water. DEM files can also be used, which could include GeoTIFFs, SDTS, ESRI grid files. ASCII files are also commonly used within point cloud creation. This is a very generic and standard format that could be comma delimited, CSV, or any other ASCII format. There are also some proprietary equipment-specific formats that are used by different manufacturers. And these typically write the data faster because they are written to work specifically with a piece of equipment. In Civil 3D, we can use all of this point cloud information, and it's stored in an external database because of the size of the datasets. That database can then be indexed to improve performance within Civil 3D, because you obviously would not want to have hundreds of millions of individual point objects within our drawing. And the view of these point clouds will be driven by Civil 3D styles.